Hello everyone, I am Kartik Dalwadi, a postgraduate student in Construction Engineering and Management at SEPT University. My student code is PCM24163. Today, I will be sharing the work I have done as part of our studio course titled Construction Project Execution, Monitoring and Control. This studio focuses on the execution phase of construction projects. It covers important stages like project commencement, planning, construction activities, and even maintenance. This phase is critical because it ensures proper use of the five major resources: time, money, manpower, machinery, and materials, all of which must be managed efficiently to meet the client's expectations. The studio brings together important knowledge areas such as cost control, quality assurance, safety protocols, project planning, and lean construction principles. In this presentation, I will show how I applied these concepts on a real life project focusing mainly on three parts: cost of quality, tools of quality, and earned value. Project brief. The project I worked on is a research center designed to become a hub for biotechnology and life science innovation. The aim of this center is to address key challenges in agriculture, healthcare, and environmental sustainability through collaboration and cutting edge research. The project is located in Gift City with a site area of 9,735 square meters and a built up area of 18,976 square meters. The estimated cost of the entire project is around 108.42 crores. The structure includes one basement, a ground floor, and six upper floors. It is scheduled to be completed over a 20-month duration, starting in September 2024 and ending in July 2026. The scope of work includes core and share construction, interior works, MEP installation, finishing, and maintenance. The contract is split into two types: item rate contract for the basement and lump sum contract for the superstructure. As of April 22nd, the major activities happening on site were reinforcement work for Pour 2 slab at the ground floor and shuttering work for Pour 1 and Pour 3 at the first floor. The cost breakdown shows that the largest portion of the budget goes to civil works, while miscellaneous post construction work makes up the smallest share. In construction, quality is often thought of just a technical concept, but when we study the cost of quality, we realize it's deeply connected to how money is spent during the project. Cost of quality is divided into three main types: prevention costs like planning, training, and setting quality standards; appraisal costs such as inspections, testing, and audits; failure costs, internal failures like rework, and external failures like customer complaints or repairs. From the analysis done in this project, we found that appraisal cost made up the largest portion, which means a lot of resources were used in inspection and testing activities. This shows how we to invest in prevention, which can reduce the need for appraisal and failure costs. In this project, we also faced non-conformities, which are deviations from expected quality. To handle them, we followed a systematic closure process as shown in the flowchart. Here's how it works. A non-conformity is identified on site. The site engineer raises the NC and reports it to the quality assurance or quality control manager. A detailed identification report is prepared by the QA/QC team and reviewed by the project manager. Based on how serious the issue is, a planned completion date is set. If the issue is high in magnitude, a third party agency is consulted for corrective action. The QA/QC team witnesses the correction before closing the NC. If the NC is low in magnitude, the QA/QC manager suggests remedial action and its effectiveness is reviewed by the QA/QC engineer. Once everything is resolved and verified, the NC is officially closed. For example, in our concrete works, we had to deal with honeycombing. The costs Due to this, non-conformity were broken down into labor, material, machinery and inspection costs. From the chart, it's clear that material and machinery costs were the highest, showing how costly rework can be. This reinforces the importance of proactive quality control to avoid such issues. To check nearly concrete performance, we used X bar and R bar control charts for M35 grade concrete samples over 7 days. All 30 samples in the X bar chart fell into within the control limits, ranging between 31.92 MPa and 36.75 MPa, which is well above the required IS code minimum. This shows that the process was stable and well controlled. However, in the R-bar chart, one sample showed a spike with a range of 6.99 MPa, getting close to the upper limit. This may indicate issues like incorrect mixing time, variation in the water-cement ratio, or poor curing conditions. These charts help us detect such problems before they lead to visible structure issues. We then did a similar check for 28 days compressive strength. Once again, all 30 samples stayed within control limits with values between 42.22 MPa and 46.70 MPa. The R-bar chart showed variability stayed within 0 to 5.65 MPa, proving that the process was very stable over the full curing period. These control charts are helpful, especially in long-term projects, because they show early signs if the project starts to drift away from the target values. To investigate the honeycombing issue, we used an Ishikawa diagram, also known as a fishbone diagram. We identified four key root causes: men, poor workmanship in machine, faulty equipment or breakdowns in material, low workability concrete, and method like incorrect pouring or vibration technique. At the same time, we analyzed slum test results of 90 concrete samples. The majority, 56 results, fell in the range of 140 to 149.9 mm, which is within the IS 456-2000 standard of 100 to 150 mm. This showed that the concrete mix itself was not the issue, but the vibration technique likely caused the honeycombing. All after identifying the problem, we applied these preventive measures: trained and skilled workforce, better on-site supervision, concrete with good workability, use of adequate vibration, option to use self-compacting concrete which doesn't need vibration. These changes helped improve quality and reduce the chances of honeycombing. To measure how the project was performing in terms of cost and time, we used earned value management. In MSP, we identified activities, created a baseline, assigned resources, and updated progress. The EVM analysis was done for tasks like shuttering, reinforcement, concreting, and curing. Based on real time data, we calculated two key values: SPI, which is Schedule Performance Index, which was less than 1, and CPI, which is Cost Performance Index, which is also less than 1. This told us that the project was behind schedule and also over budget during the look ahead period from 15th April to 29th April 2020. We also used Primavera P6 to do the same analysis. The steps included importing data, assigning resources, and generating an S curve which visually showed the project progress. Here are the values: planned value as 94,274, earned value as 65,991, and actual cost as 93,375 rupees. Again, the SPI was 0. 0.7 and CPI was 0.71, showing the same outcome as MS Project. Although both software tools gave the same results, Primavera P6 proved to be more efficient. It allowed us to directly update actual units and costs, saving time and reducing chances of error. On the other hand, MS Project required manual cost entries, which is more time consuming. So we conclude MS Project is good for small to medium projects due to its simplicity and low cost. Primavera P6 is better for large scale projects because its advanced features, even though it requires more training and setup time. This comparison helped us understand which tool is more suitable based on project size and complexity. To conclude, we explored how quality control and cost management directly affect project success. We used tools like control charts, Ishikawa diagram, and EVM to detect issues early and improve outcomes. We also compared MS Project and Primavera to find the right software depending on the project skill. Most importantly, we learned that proactive planning and early action can prevent delays and reduce unnecessary costs. This studio gave me a real hands on understanding of how construction processes are managed on an actual site. Thank you so much for watching, and I hope this presentation gave you useful insights.